Okay, in this video we'll look at captions, and also we'll mention something else that's also numbered, equations or examples that don't really fit in either of the common categories. So again, one of the most important things to realize is that graphics should stand alone from the text. An experienced reader should be able to look at the graphic and the caption and know basically what they are seeing. They should be able to identify the important points. On the other hand, the text should not duplicate the information that's in the graphic. It can summarize it. It can highlight different things to look at, as we mentioned in the last video. It can add additional information, but it shouldn't be exactly the same. And the caption, both the location and the format, in some journals, some situations, is identical. In other cases, not. Here's an example, for instance, from IEEE, the electrical engineering format. And you see that for the table, the table has the title above, it's centered, and the caption for the table is on the next line. And all of that is in small caps. On the other hand, for the figure, the title is below, it's in normal font, it's on one line, and it's left justified instead of being centered on the page. And in engineering, it's very frequent for titles, the captions for a figure, to be several lines long because they often have sub-figures within them. Whereas again, this is different in other fields like the humanities where they tend to be on one line. So tell us a little bit about the APA format and how that's changed.
We have to follow the most current APA style. The 7th edition tells us to put both the captions for tables and figures on top, not traditionally tables on top, figures on the bottom. So we need to pay attention to the changes. For example, in the first column of table 4, you can see such and such. The second column, the third column, and so on. So we are very friendly. We need to hold the reader's hand to show them where to look for the information. And also, when we do the captions, many times we have to delete some definite articles. So for example, table 4, average scores instead of the average scores. So that's how captions or titles are different when it's written that way versus in a text.
Mm-hmm. So again, there's a difference between the location, the common location. In many fields that use IMRD, most of the tables, figures, examples, at least in a journal article, will be in the results and discussion. But again, that differs if you're writing a thesis.
Exactly. When you write a thesis in your chapter 2, which is the literature review, especially in education, we tend to ask students to summarize the literature they have reviewed in a table. So it's in addition to the text, you also need to provide a succinct table. And also in methodology, instead of writing about the theoretical framework and the procedures, we also ask the students to provide a table or a figure summarizing what they have just said, so we can see clearly what they just said. It's very user-friendly.
Yes, well, engineering is not very user-friendly. In many cases, it simply points to the table or figure and assumes that the reader is smart enough to figure it out. And so in engineering, again, we have a slightly different expectation for where the tables and figures would be. Almost all of the tables are going to be in the testing because that is presenting results. And any figures that deal with the results are also there. But in engineering, you almost always have some figures in either the introduction or the process division that show the whole design, because it's a new design and it's often easier to depict it in a figure rather than in many, many lines of text.
Going back to your comment on user-friendly, I wouldn't say that the engineering people are not user-friendly, but we have to see there's a limitation of words in engineering articles.
Sure.
Sometimes it tends to be shorter and it has to be published faster. But in humanities and social sciences, sometimes, our strength is on using words to illustrate, to explain, to argue. That's our focus. And we need time to make sure our arguments are solid. And it takes time to explain everything. It takes, many pages to illustrate a point. That's the difference. We are both user-friendly.
Okay, well, thank you for providing a good excuse for the engineers. Okay, as I mentioned, there are other numbered units in both humanities and engineering. In the humanities, you have examples. In engineering, you often have equations. These are not really graphics, but we don't cover them anywhere else in this video series, so I'll mention them here. They also are numbered sequentially throughout, but they're just numbered in parentheses rather than saying example X or equation X, as in these two. So the first one is an example. Examples are very common as data in humanities and social sciences. And usually they're referred to and then followed by the actual example, but it's a separate sentence. Whereas in engineering, often the equations are sort of part of the sentence. For instance, this one, the innermost region is defined as, and then that equation is actually part of the sentence. And the sentence actually goes on beyond that, describing more about the situation in which it's used. Notice also that the position of the number is different, with examples on the left-hand side and equations putting the number on the right-hand side. So in the next video, we'll be looking at how you make a good table, how you improve your tables, and then in the final one, we'll look more at figures.